iteration, I think. Yeah. Fixed point iterations we studied, and we discussed about the single variable fixed point iteration technique and the multivariable fixed point iteration technique. Then I had switched to Newton-Raphson method, and I had discussed about single variable Newton-Raphson method and the multivariable Newton-Raphson method. So any of you have any queries or anything? Then otherwise I'll just give a quick recap. You can stop me whenever you want, and we can discuss. So in fixed point iteration method, basically, the basic algorithm goes like you have an equation will be given with f of x equals to 0. So what we do is we use the concept of recasting. That is, we rewrite this function f of x equals to 0, this equation basically, as in this form x equal to g of x. So now you might ask me that there can be multiple ways of writing that function, that g of x can be anything. Yeah, it can be anything, but it is by trial and error that we decide which g of x we should choose, so that it gives us the convergence. So we'll see the examples, then it will be clear to you. Now, this function fx equals to 0, once we rewrite it as x equals to g of x, and then if we draw the curves y equal to x and y equal to g of x, then basically the intersection point of these two curves will give me the solution of the original equation. Because f of x equals to 0, that only we have rewritten as x equals to g of x. So basically x equals to g of x means we draw the two curves y equals to x and y equals to g of x, and then the intersection point of those two curves basically gives me the original solution. So by using this concept of recasting, we approach towards the intersection point of these two curves, that is y equals to x and y equal to g of x. So this is also an open method where we'll be given with the initial guess, and we'll start from the initial guess, and then we will gradually move till convergence is achieved. So here you can see you have an equation like f of x equals to x minus e power x by 3 equals to 0. So you need to find the solution for this equation, the value of x, by using fixed point iteration method. So now your initial value x of 1 is given as 1.25. Fine. So now this x minus e power x by 3 equals to 0. If I tell you to write it in this form, x equals to g of x, then we can write it in multiple ways. Here I have shown three possible ways. So the first one is we can write x equals to e power x by 3. So that basically means that our g of x here is the recasting function is e power x by 3, right? Also, we can write it as, if we rewrite this equation as 3x equals to e power x, then basically if we apply log on both sides, that is the part B I am talking about, we can write x equals to ln of 3x. Again, then your g of x will be ln of 3x, correct? So on again, third possibility is we can write this as x equals to 2x minus e power x by 3. Again, this is also of the form of x equals to g of x. So again, this g of x here is now 2x minus e power x by 3. So these are the different possibilities or the options of recasting this particular equation. Now we will see with each recasting function what is my convergence rate, or whether my solution is converging at all, or whether it is diverging. So the first here, x equals to e power x by 3, what we do is basically, first we use this x of 1 equals to 1.25, that as the initial value, and we substitute it in the recasting function. So basically your x of 2 will be e power 1.25 by 3. So it is 1.163. Like this, if we go on substituting x of 3 e power 1.63 by 3, and we go on substituting till we achieve convergence, we'll see that after around 20 iterations, we'll get the solution, which is 0.619. So here I showed you through the MATLAB code that depending on this choice of the recasting function, I have not done for the other functions. If you do for the other functions, you will see that the number of iterations which are required for convergence will vary depending on the recasting function. Also, depending on the initial guess of the solution, your convergence will vary. For some initial values, I had showed you that your solution will not at all converge, rather it will diverge from the actual solution. So we can conclude from this that the convergence, that basically depends on the choice of the recasting function and the initial guess of the solution. Okay. So this was about the fixed point iteration scheme with the single variable. So then we move to the multivariable fixed point iteration scheme, where we had basically two. So here you'll have two variables and two unknown variables and two equations, using which you have to solve for the unknown variables. So here also the process remains the same. Like here there are two variables, right? So there will be the initial value matrix that will be a 2 cross 1 matrix, which is given as y of 1 is given as zero point 0.5 and zero point 0.5, and these are the two equations. So here the two unknown variables are y2 and y3. So what you have to basically do, from the first equation you form the equation y2 equals to g of y2, and from the third equation you form y3 equals to g of y3. So if you do this, you will get, this is g1 of y2 and this is g2 of y2 y3, like this. So you can see here, as I have marked here, this is your first equation and this is your second equation. So if you do this, so if I do this for the first equation, it is 4 minus this one. So if you substitute this, we'll get y2 equals to in this form. So this is your basically 4y3 plus 2y2 cube minus 4 by 8. This is your basically g1. That is the first recasting function. Similarly, if I do for the second equation, I will get another recasting function. So this is my g1 and G2, this is my G2. So this is my second equation. This is G2. This is G1. So what we do is, from the first equation, y2 of 2 is g of y2 of 1 comma y3 of 1. So your y2 of 2 will be basically equal to g1 of y1 of 1, y2 of 1 and y3 of 1. So y2 of 1 and y3 of 1 are given to you. So basically you substitute here, you get a value of y2 of 2. Similarly, you do it for y3. So after the first iteration, your y is minus 7 by 32 and 1 by 4. Again, you substitute this in the next iteration. Then like this, you will get a matrix of two solutions, y2 and y3. And till the tolerance limit is achieved, we repeat this iteration. So I had given a homework for writing a MATLAB code from multivariable fixed point iteration. So I've received only 1% the homework I have received. Okay, fine. So you can visualize this. If you write the MATLAB code for this, you can visualize in how many iterations we are basically getting the solution. You can just visualize using a different initial value and then seeing how many iterations it is taking. All you can visualize. Just a second. So this is basically the fixed point iteration scheme. So just remember this thing, in fixed point iteration scheme, your convergence will depend on your initial solution, the initial guess of the solution which will be given to you, and the recasting function that you are using. And the choice of the recasting function has to be on trial and error basis. Then we move to another most important technique of numerical solution of nonlinear equations, which is your Newton-Raphson method. So in Newton-Raphson method, what it is an open method. Basically, you will be given an initial value and you have to get the actual solution. So here also convergence will depend on the uh, initial value of the given in the problem, as well as the function which you are using here. So first let us understand the graphical approach behind this. So this red curve here in this graph, that basically shows the function, that is f of x equals to 0 you are solving. So this is my f of x, and you'll be, as I told you, you'll be given with the initial solution. Yes, Raj, you want to say something?
No, no, just by mistake was open. And I'm sorry for the delay,
Okay.
like I got enough time to.
Yeah, fine, no issues. So this red colored graph here is the actual function f of x, and x1 here, as I have marked here, this is the initial value which is given to you. So, and you can see here, the solution is at this point, right? The intersection of the function with the x-axis. So x1 is my initial value and we have to approach towards the actual solution. This is my actual solution. So what is the principle of the mathematics applied here? Basically, So what we do is we find the value of this function at the initial value. That is, we draw a vertical line from x1 and find the meeting point with the curve. So this green point here, this one blue point, this is the intersection point. So what we do is we draw a tangent to the curve at this point. So this is my tangent, right? So this is my tangent. And then we extend the tangent to find the point where it intersects the x-axis. So this is my new solution. That is, initial solution was x2. After performing the first iteration, my solution is x2. It was the x1 first, then we move to x2. Then we again repeat the same procedure. We find the functional value at x2, that is, we extend a vertical line here. Again, we draw a tangent to that intersection point and we achieve at x3. And then we do this, and soon we will approach towards the actual solution. So from this is the geometrical approach, right? So now we need to understand that what is uh, the iterative formula which we need to use. We can't do this by geometrical approach every time when we write a code or something. So we need to find a iterative formula for the next iterative function. So what we do is, so what is my solution here? You just try to understand. It is the intersection point of the tangent with the x-axis. So somehow if I can find the equation of the tangent and then I equate the y value of that equation to 0, we will find our iterative formula. So what is the equation of the tangent here? Just note it carefully. So the first tangent I am talking about, this tangent, okay? So if you see this equation, what is the equation of a line? It is basically y minus y1 equal to slope into x minus x1. So x1 and y1 are the points through which the straight line is passing. So you know one coordinate here, that is this coordinate. What is it? x1 and f of x1. So it is basically y minus y1 is here f of x1 equals to what is the slope of this line. So the slope of the tangent will be equal to the slope of the curve at this point, at this intersection point, that is x1 f of x1. So it is basically the slope of the line is basically f dash x1, the derivative of the function at that particular x1 multiplied by x minus x1. So now as I told you, this is the equation, this is the tangent equation, right? So from this tangent equation, now I want to find out the solution. What is the solution? It is the intersection point of the tangent with the x-axis. So in x-axis, we know that y is 0. So in this equation, we basically find substitute y equals to 0 and we find out the x. So what is x here? If we substitute y equals to 0, so it is minus fx1 into f dash x1. This x we are replacing by x2. Any x n you can write. So x minus, rather we'll write it x here. So now from this you can find out what is your x. So x is basically x1 minus f of x1 by f dash x1. So if we generalize this like this, again x3 will be equals to x2 minus f of x2 by f dash x2. So basically xk plus 1 will be equals to xk minus f of xk by f dash xk. So this is the iterative formula for Newton-Raphson method. So is it clear how I derived this formula? Is it clear with everyone?
Yes, sir.
Okay. So using this, we find out the next value of x in the iterations, and we stop when the tolerance value is reached. So this was about the single variable Newton-Raphson method. So now we move to the multivariable Newton-Raphson method. So again, the concept is same, only your iterative formula will change. So here you have basically two equations with two unknowns. X and y are the two unknowns, and these are the two equations which are given to you. And your initial value is given as x of 0, which is equals to 1, 1. That is, in the right you can see here I have given. So basically your x of 0 is 1 and your y of 0 is 1. So this is the meaning of the initial matrix. So just try to understand, in one variable, single variable, we basically obtained xk plus 1 equals to xk minus fxk by f dash xk. So if we just reframe this equation, it is basically xk minus, we can write like this, 1 by f dash xk into f of xk. So what will happen in multivariable equation? So it will be basically xi plus 1 equals to xi minus. So this 1 by f dash xk in single variable, that basically translates to a matrix which is known as the Jacobian matrix. So that basically translates to J inverse of xi. So J matrix is basically representative of the derivative of the function. So here you have two variables. So you will not have differentiation only with respect to x, also you will have with respect to y. So we'll see what is our Jacobian matrix. So your Jacobian matrix for two variable system is like this: dou f by dou x, dou f by dou y, dou g by dou x, and dou g by dou y. So this matrix you have to calculate at xi. It is written here at xi, right? So for this equation, we try to find out what is dou f by dou x, dou f by dou y, and the partial derivative of g with respect to x and y. So dou f by dou x you can find out. Similarly, all these four you can find out. Now you have your initial matrix value, right? 1, 1. So basically your x of 0 is 1 and y of 0 is 1. So you substitute this in this partial derivative values and you form the J matrix. So your J matrix is, you can find out. Then your, this is your iterative formula. x2 equals to x1 minus J inverse x1 into f dash f of x1. So we substitute this, x1 y1 is 1 1 minus Jacobian matrix. I'm just replacing it like this: j11 j12 j21 j22. This inverse we have to get fx1 y1, and this part is the functional value, right? So we are currently at step 2, so we'll be substituting x1 y1 and x1 y1 here. So if you simplify this, you will get, this is your J matrix, this is your J inverse, and this is your x2 y2. This is just one iteration. After this, again you have to compute Jacobian matrix. Then you have to perform the same process again to find out x of 3 and y of 3. So you can understand that this is very computationally very expensive method, right? So what we do is, basically this method is difficult, more than one or two iterations, it's difficult to do by hand. So we take the help of MATLAB and we solve this equation. So last class I had shown you how to code this in MATLAB, the Jacobian matrix and all. You can refer to the recordings of the last class and you can refer them. So this was all which what we had discussed in the last class. So you have any questions, any doubts, anything, you can tell me. Just 5 minutes you take and you can tell me if you have any questions or confusion. Otherwise, I'll start the next topic, which is the regression. Regression analysis will start. Fine for everyone?
Yes, sir.
Okay. So we'll start today's class. Okay. So we'll start with regression today. Any one of you have any idea on what is regression? At least the basic idea of linear regression, anything? Anyone?
No, sir.
Okay. Anyone else? Any idea on regression?
So, yeah, Samit, I think regression is something repetition, or like in that sense it is coming repeating some values to optimize.
Can you just repeat what you told?
I was telling ki regression can be a kind of repetition. Am I going in the right direction? I don't know, but I think
No, no, no.
some
It
kind
is
of
repetition means repetition of what you can elaborate.
like suppose we want to come to an optimized value, so maybe we will be doing an iteration till the optimized value comes up, like that it is.
Not exactly.
I
Near.
think, sir,
Yeah.
it is depends on independent variable based, independent dependent variable based work.
Yeah. What you're telling? Can you repeat once again?
I think, sir, it is depends on independent and dependent variable.
Yeah. It depends on dependent and independent variable. But what is regression? Any idea?
No, sir.
How? Okay, fine. How do you choose the dependent and independent variable in any? Suppose you are given a problem. How do you choose the dependent and the independent variable? Any idea? Yes, Mustafa.
Sir,
Any idea?
few months ago, I will try machine learning.
Okay.
Uh,
Yeah, machine learning that involves regression.
these are regression, logistic regression, linear regression, kind
So
of.
what you have understood of regression? If you have used machine learning, that means you know regression.
There is a algorithm for regression, linear regression.
What is the basic purpose of regression? At least that much you can tell.
Forget it. Uh, 6 months ago.
Okay,
That's
okay,
what I
fine. Okay,
forget
fine.
it.
Anyone else? Any idea on regression? At least a basic idea, I think everyone will have what is on regression.
It's statistically like we try to create a relationship between all those independent variables from the what do you say? I don't have the word, but you try to create a relationship between these
Yeah,
variables,
yeah.
like
Understood. Yeah. Yeah, it is actually you have a set of, suppose you have performed an experiment, right? And you have two sets of data based on your dependent variable. Uh, you have two sets of data, say X and Y, I am telling. From that, you try to propose a relation between your dependent and the independent variable. So you try to predict what is the, okay, I'll show you one graph here. Suppose this is your XY curve, and here you have, say, you have obtained lot of data like this. Like this is random. Suppose you have like this. Suppose you have some data like this. This is your, these are the data points, right? So this is just basically the scatter plot of the any experimental result I'm telling you. Okay. So you try to find out a relation between this dependent and the independent variable. So first we'll learn about linear regression. We'll only concentrate on linear regression. Okay. So what is the most accurate line or the most accurate straight line that you can draw such that it is very close or at least or passes through all of these points? There can be multiple straight lines here, right? Suppose I draw a straight line like this. This green one is one straight line. Okay. You can also draw another straight line which passes through this. You can also draw another straight line like this. One straight line, as I told, it can be like this. Another straight line, it can be like this. So there can be multiple straight lines to represent your data set. Now, so you can see here, all of your data points will not lie on a single straight line. But we need to understand that one of the straight lines out of this is the closest to all these data variables, all these data points. So that is called the best line of fit. So here you can see, so now how do you determine what is called the best line of fit? So before that, I'll just give you a few, is the basic concept clear about regression? So it is as one of you told, it is basically to propose a relation or to find a straight line for linear regression which closely predicts your data points. So that is the basic essence of regression. So after regression, we will see another topic which is known as interpolation and extrapolation. So there I will tell you what is the difference between regression and interpolation. Okay, so for the time being, let us concentrate on what is regression and let us try to understand. So your regression is basically, it is the prediction of the dependent variable, right? So I'll just erase
Yes,
this and
sir.
I'll, yeah, yes, you want to say something, Mustafa?
No, sir. No, sir.
Okay. Regression is basically prediction of the value of the dependent variable. So it is to find a correlation. The basic purpose of regression is to find a correlation or a direct relation between the dependent and the independent variable. Now, in a correlation between two variables, two things can happen. First one can be your y value, that is, so here dependent variable is y and independent variable is x. Okay, so if your y increases with increase in x, it is called as positive correlation. That is, your correlation coefficient will be greater than 1. And if your x, sorry, if your y if y decreases with increase in x, it is called as negative correlation. That is, your correlation coefficient is less than 1. So what is the necessity of regression from this you understood? It is basically to predict a relationship between two variables. Okay. So in linear regression, it is to predict a linear relationship between two variables. So, so how we do that? The first I'll discuss the algorithm, then I'll take one problem and then I will try to solve it. So what is the basic algorithm? So first step is we tabulate our experimental data. So whatever data you have, you just tabulate it properly. The independent variables in one column and the dependent variable in another column. Tabulate your experimental data. First, tabulate your experimental data. So then, second step is draw a straight line along the plot. So let the equation be a naught x, sorry, it is a naught plus a1x. Let this be the equation of the plot. And here our job will be to find the equation of this straight line, right? Find a naught and a1. Basically, we have to do that. So as I gave you the example in the last, the plot which I showed you, I'll draw it once again. So suppose this is y, this is x, right? So suppose you have 4 data points like this. One more here. So I can draw one straight line, I can draw like this. Another straight line I can draw like this. These two lines I'm telling you. I'm telling this blue one is line 1, this one is line 2. So can you tell me which is the most accurate representation of the data? Whether it is line 1 or line 2?
Line 1, sir.
Why is it line 1? Can you explain? Yes, Mustafa?
It fit most of the point
Yeah,
line.
correct.
Yes.
It passes through most of the points, right?
Yes, sir.
Okay. So I'll give you one more example, then it will be clearer to you. Suppose you have one point here, one point here. Like this, you have some more points. So you have one more point here. So if you have like this, you can again I can draw like this. So in this, can you tell which is more this, if this is line 1 and this is line 2, which one is more accurate? Anyone?
So line 1.
Why? Your line 1 passes through 3. Okay, one more point I'll give here. Wait. Just take another point here. So your line 1 passes through 4 points. Line 2 also passes through 4 points. So how do you decide which one is more accurate?
I think one method can be we don't see which the L1 or L2 is exactly passing through that point or not, but we can see what is the minimum distance, like perpendicular distance between the points and it. If it is very far, then we can't consider it on the curve. If it's little near, so like that we can approach.
Yeah. So let me mark all these points. Let this be x1. Let this be x2. Let this point be x3. Let this be x4. This be x5. x6. Let this be x7. So first we will take line 1. Okay. So according to the line 1, you will have some equation, right, of this line 1. Say it is y equals to a naught plus a1x. And for line 2, you have say y equals to a2 plus a3x. So what you do is line 1, your actual y for different values of x. Okay, so this is like, this is my x, y predicted by L1, y predicted by L2, and y actual. So this y actual, you have your values, that is for x1, x2, x3 to x7, you have your y actuals, right? So it is basically y1, y2, y3, y4, like this up to y7. And what is the value of, this is the, for x1 you have your y actual is y1. So you try to find out for L1 line, which is y equals to a0 plus a1x, you try to find out what it is predicting. So it is predicting a0 plus a1x1. Similarly, your L2 is predicting a2 plus a3x1. Like this, for all these x till 7, you find out all this. Then you find out the percentage error for L1 and the L2. So how do you find out the error? Then the next question. So here, what is your error? Error is y actual, that is the true value, minus a1 a0 plus a1 xi. That is, for the first value it will be y true, that is y1 here, minus a0 plus a1 x1. So this is your error. Again, like this, we could have all E1, E2, E3. Similarly, for line 2 also you can find out. Then you compare in which one the error is more. So if the error is more, that means that particular line is not predicting your data correctly. So wherever the error is less, that is your the best fit line. Is this concept clear? Is it clear, or should I repeat it once again?
Sir, can you repeat it once again?
So why did you face the problem? Okay, so the thing is, you
The
have your
error.
data points, x1 to x7, you have your data points. And you also have what are the values of y for those particular x1 to x7. So you make a table from x1 to x7 in one column and y actual, that is y1 to y7 in the another column. Then you find out what is the value of y predicted by line L1 and what is the value of y predicted by line L2. You know your true value, which is y1, and as predicted by L1 it is a0 plus a1x1. Similarly, for L2 it is a2 plus a3x1 for x1. Then you find out the errors for each one. For each data point you find out what is the error by line L1, what is the error by line L2. Then the wherever the error is less, that line is actually your line of best fit. So now here one problem will arise. The thing is, if you use this formula for error, y true minus this one, so this one can be a negative or positive, right? So suppose some errors are positive, say here error is +1, here error is -2, here error is +1, here error is +1, here error is -1, and here again error is +1. Sorry, here error is -1. So what is the total error? If you sum up EL1, it is 2, 3, -2, 1. Sorry, here let the 1 second. +1, 3, 2. This is also same. Here it is -1. Here it is -1. So if you sum up all this, it will be, your error will be 0. So that shows you, that gives a wrong impression that there is no error. Basically, if you sum up this error, that gives you 0. So that gives an impression that it is the most accurate, but it is not, because since you have not taken the mod value or the absolute value of this, that's why it is giving you some 0. If you take the actual mod value and sum up, it will be around 3, 3, 6. So this is your error, actual error. So you have to use the mod value always. So your error formula will be summation I equals to 1 to n, that is the number of data points, modulus of yi, that is the y true, minus the equation of the line, that is a naught plus a1x. So this is one formula for error. Or if you want a better approximation of the error, so this is the total error, right? The total error. Or you can also use another formula, which is the sum of the squares of the error. So it is basically summation I equals to 1 to n yi minus a naught plus a1 xi. So if you do the sum of squares of the error, that gives you a more better picture of your error. So now what was our goal? So as I told you, this error has to be minimum, right? So our goal will be to minimize this E. Minimize this E, and for that minimum, you find out your A0 and A1. So what we do is basically, when is a function minimized? When the derivative of the function is 0. So we differentiate this function dou E by dou A0 equals to 0 and dou E by dou A1 equals to 0. If we differentiate this function, so that is an algebraic procedure. From that, you have to find out your A0 and A1. So I'll directly write the formula for A0 and A1. So A0 is summation yi minus A1 summation xi upon n, where A1 is summation xi summation yi minus n summation xi yi upon summation xi whole square minus summation xi square. So these are the two formulas for linear regression for finding the coefficients of the best fit line. So these are the two formulas. So how you achieve these formulas? This is the reason or the basic funda behind understanding this thing. So what you do is you find out the error and you differentiate it with respect to the two coefficients and equate it to 0. And obviously, if we equate it to 0, we will get two values, right? One will be for maxima, other will be for minima. And again, then we have to take the second derivative, and for minima, that second derivative has to be positive. So that algebra we can do, and finally we will be arriving at these two formulas for A0 and A1. Is this clear? Any doubts?
No, sir.
Okay, fine. Just take a 5 minutes break and I'll come back. Okay. So I'll start. So these are the basically this for the linear regression. These are the two coefficients a0 and a1 which we need to determine for the for expressing the line of best fit. So now we will see what if the data is not linear. How we can linearize a non-linear data. So how do we linearize? So basically it is linearization of non-linear data. Suppose first we will look into one form which is the exponential form. So say we have an equation of this form a e power bx. So this equation, can we just manipulate this equation or change the variable somewhat to get a linear form? This is the relation between y and x and y here. It is not linear, it is exponential, right? So what we can do here to make it a linear equation? So what if we apply log on both sides? So it is ln a e power bx. So that will basically give me ln y equal to ln a plus ln e power bx, right? So that will give me ln y equals to ln a plus bx, right? So if you see this equation, if we change our dependent variable from y to ln y, let it be the new dependent variable which is y dashed. This is my a naught, this is my a1, and this is my dependent variable x. So now if we write it as y dash equal to a naught plus a1x. So this is a linear relationship, right? So this is how you convert from a non-linear data, a non-linear relationship between x and y, to a relationship, to a linear relationship between a different variable by manipulating the equation. Is it clear?
Yes, sir.
Okay. One more form I'll just discuss here. Suppose you have y equal to x upon ax plus b. So this type of equation, this is again not a linear relationship between x and y. But if we just manipulate this, so this we can write as 1 by y equals to a plus 1 by x into b. So now if you just change this variable to this to y dash equal to a plus x dash into b. So now from this relation, this y dash and x dash, that has a linear relationship. That is 1 by y and 1 by x has a linear relationship. So why we are doing this? Because let us say we have a problem. You have a set of data and you are seeing it is not a straight line. Say you have, for the first one, suppose you have, say, a data like this. Suppose you have some data like this, right? So you can understand that we cannot fit a linear data to this, a linear curve to this. What this looks like an exponential data, right? Say like this. This looks like an exponential data. So then if you want to fit it to an exponential data, we need these coefficients a and b. However, this one what we explained here, a0 and a1, this is only for linear data. So somehow we need to change the variables y and x here and then convert it into a linear equation so that we can apply the previous formula and get the coefficients value. So if we change this variable y to y dashed, that is we from y we compute ln y and our dependent variable remains the same, then we can find out a relation between y dash and x which is linear. So here you can just change the dependent variable y to ln y and then just treat it as y and find a relationship between this new y and x. From that you will get a0 and a1. So once you get a0 and a1, then you can just resubstitute it here and you can get this A and B. How you can get A and B in terms of A0 and A1? See, if you compare these two equations, ln y equals to ln a plus bx and y dash equal to a0 plus a1x, you can see here your a0 is equal to ln of a. So what is your a here? E power a0. You know a0 from the regression. You can find out what is e power a0. That is your a here. What is b? B is basically equals to a1. So a nonlinear data also you can linearize and then find the coefficients. Similarly, here also if you see, what is the equation we are getting? It is 1 by y equals to a plus 1 by x into b. So now you fit linear data to 1 by y and 1 by x, right? So you get y dash equal to a0 plus a1x x dash. So if you compare this with this, directly you can write a0 will be equals to a and a1 will be equals to b. From this you can find out your a0 and a1, a and b rather. So is it clear or should I explain it again? Is the concept clear? Anyone else? Any doubts? Okay, fine. Then we'll see two problems and then we'll close up today's class. So three problems we will see and one more matrix approach we will see. Okay. Okay, first we'll look into the matrix approach. What is my matrix approach? Suppose you have a set of data which is given by x1, y1, then you have x2, y2, like this up to say n data points are there, x and y n. So you are told to fit it into some equation is given and you are told to find the best fit line. So So this is the equation of the best fit line. Suppose y equals to a0 plus a1x. So it should be y2 equals to a0 plus a1x2. Again, y3 should be equals to like this up to say yn. It should be a0 plus a1 into xn. Right. So just if you instead of finding like this using the formula, if you don't want to remember the formulas a0 and a1, what you can do is you can form a matrix kind of thing. So from this equation, if I form a matrix given by y matrix, if I say y1, y2, like this up to yn. So this size is n cross 1. And if we form another matrix which is x, which is given by 1, x1, 1, x2, dot, 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 up to n, 1, xn, suppose. So what is the size of this matrix? This is n cross 2. Suppose these are the two matrices, y and x. So now another matrix will be there, which will consist of your a0, a1, all these things, right? Suppose I have another matrix which is phi, which is given by a0 and a1. So this is your coefficient matrix. This is 2 cross 1. So if we just write like this, x into phi, what is my x? 1, x1, 1, x2, up to 1, xn. Phi is a0 and a1. So first of all, is this multiplication possible? Because this is n cross 2, this is 2 cross 1. So yes, the column number of this matrix and row number of the second matrix matches. So what will be the output matrix size? It will be n cross 1, right? So it is basically first row into first column. So it should be first column a0 plus a1x1, second column a0 plus a1x2. Like this, we'll have a0 plus A1 into Xn. This is n cross 1. So this matrix is nothing but your Y matrix, right? So we can write Y is given by X into phi. So from this directly we can find out phi, which is X inverse Y. But in this relation there is a problem. Can you tell me just by looking at this matrix X, what is the problem here? Any one of you? I am saying that this relation is correct, y equals to x phi. But from that, if we want to find out phi, it should be x inverse y. But I'm telling that this relation, there is a problem. You cannot evaluate like this. Phi, you cannot evaluate phi matrix. There is a coefficient matrix. You cannot evaluate by finding out x inverse and multiplying it with y.
Yeah, I think because x inverse is x is not
Yeah, x is not.
yeah x is not a square matrix, so finding inverse will not be possible in this case, I guess.
Yeah, correct. So for a matrix to be invertible, it should be a square matrix, right? But here you can see your X matrix is not a square matrix. So this is my X matrix, right? This is not a square matrix. So this way you cannot solve this. Although y is equal to x of phi, but this phi equal to x inverse y will not work here. So how to make any non-square matrix or a rectangular matrix to a what do you call it? To a square matrix. We multiply it with the transpose of that matrix, right? So if you multiply here both sides of this equation with x transpose, what will be the thing? X transpose x phi. Now, if you find out phi from this, it will be x transpose x whole inverse multiplied by x transpose y. So now this is this we can evaluate. See, x transpose x is, what is the size of x transpose x? X transpose size is 2 cross n and x size is n cross 2. So size of x transpose x is 2 cross 2. It is a square matrix. You can evaluate the inverse. Then you can multiply it with x transpose and y. So this is the way by which we can evaluate without remembering that formula for A0 and A1. Directly using the matrix approach, you can evaluate the coefficients. Is this concept clear? Any doubts, anyone? Any confusions?
No, sir.
Okay. Okay. So these are the two ways. One is the matrix approach and the other is the normal approach by which we can find the regression coefficients. So now we'll see two problems here, one with linearization of data and another one with non-linearization of data. Suppose you have a problem, say you are given a table like this. Suppose the tabulated values of x are 5, 10, 15, 20, and this is 10, 55, 92, 100. And we have to perform a, so the question here is perform linear regression to find out y equals to a naught plus a1x. That is, to find out a naught and a1 here. Okay. So first we'll do it using the normal approach, then we'll see with the matrix approach. Or first we'll first we'll do it the normal approach. So we have to find out a naught and a1, right? So what is a1? A1 is summation xy summation yi minus n summation xi yi upon summation xi whole square the summation xi square, and your a naught is summation yi minus a1 summation xi upon 50. These are the two formulas. So now you need to prepare the table. So your xi, yi, what all we need? Summation xi, summation yi. So xi square we need, right? Xi square, and we need xi yi. So 5, 10, 15, 20, yi is 10, 55, 92, and 120. Xi square is 25, 100, 225, 400. Xi yi is here 5 into 10, 50, 550. This is 15 to the 30, 59 is the 1380. 2400. So you have this. Now you need to find out summation of all this. So for A1 you need summation xi, we need summation yi separately, then you need summation xi yi separately, again summation xi square minus summation xi square. So we'll find out what is summation xi first. So it is 5 plus 10 plus 15 plus 20, right? 15, 30, 50. Summation yi is how much? 10, 55, 92 and 120, right? So it is basically 277 summation xi square. So just remember this, in this formula, this is summation xi whole square and this is summation xi square. These two are different. Summation xi whole square means you find out what is the sum of all the xi's and then square it. Whereas summation xi square means you have to find out all the xi squares and then sum it. So summation xi square is this sum of this third column, 2500, 225, 400. So it is 500, 500 plus 250, it is 750. Summation xi is 50. Summation yi is how much? 277. Summation xi square is 750. And summation xi yi is how much? Sum of this fourth column, all the elements here, 550, 600, 600, 3000, 4380. Yeah. Now there is nothing else. You have to just apply the formula. It is summation xi summation yi minus n summation xi yi by summation xi whole square minus n summation xi square. So summation xi is 50, summation yi 277 minus n means the number of observations, that is number of data points. So it is 4 here. Summation xi yi is 4380 by this is 2. This is 50 square, summation xi square minus 4 into 750. So this, if you simplify, you will get 7.34. And similarly, A naught, it is summation yi n summation, sorry, not n, A1 into summation xi on n. So what is summation yi? It is 277 minus A1 is 7.34 into summation xi, that is 50 upon 4. So if you simplify this, this will come around minus 22.5. So A naught and A1 both you have got. So what is the equation? Now y equals to A naught plus, which gives me y equals to A1 is 7.34, right? 7.34x minus 22.5. So I'll show you in MATLAB how it is close to all these points. Just one more problem we will do, the non-linearization, and then we will see. Is this clear? Any confusions anywhere, anyone?
No, sir.
Did you get how we are doing the problem, right? So how did you get this A naught and A1? That this formula you have to remember, but if you by chance if you forget the formula, just remember how we achieved this. It is through minimization of the error, right? Okay. So now another problem we will do, that will be non-linear data, right? Suppose you have two variables are there, t and p. Okay, 1.8, 2.6 and 3.4. Here you have 0.1, 0.5, 1.5, 4.4. So your dependent variable here, this is x. This is your dependent variable t. T is, I'll write x and y only. X and y. Okay. So now it is told that this model follows the equation y equals to alpha e power beta x. So this is the relation is told y equals to alpha e power beta x. You have to find alpha and beta here. So here you can see directly you don't have a linear relationship, right? So we need to convert it into linear relationship. How do we do that? As I told, it is basically ln y equal to ln alpha plus beta x. So we have to find out ln y dash equal to ln alpha plus beta into x. So here this one, if you just replace y dash equal to a naught plus a1x. So from the linear regression, you find out a naught and a1 using the normal formula. Then you substitute a naught equals to ln alpha. So that will be alpha equal to e to the power a naught, and your beta will directly be equal to a. So this is the funda. So I'll show you how to do that. So the first step here is you just identify what are the variables now. It is not x and y, it is rather ln y and x here, right? So x is already there with me, so I find out ln y. So ln of 1 is 0, ln of 1.8 if you calculate. 1 second. Sorry, ln of y, right? So ln of 0.1 is minus 2.303. ln of 0.5 is, I've already computed this. You can do this in calculator. 0.693. ln of 1.5 is 0.405. And this is 1.482. So now this is your y dash, right? So you need x I into yi dash xi square, these two, right? So everything you just forget y now. So your y is now changed to y dash, which is ln y. So x into y dash, it is minus 2.303. Then this is minus 1.247. This is 1.053, 5.039. And xi square 3.2476. 34 square is 511.56. Is this clear or some confusions are there? You can tell me. So now you find out the summations. So summation of xi, it is 8.8. So another unit summation yi. So yi is not y here, yi dashed, right? So if you sum up this all this third column, it will come to minus 1.109. Summation xi yi dash equals to this one. If you sum up, it will come to 2.542. Summation xi square is 22.56. Now from this, you can substitute this in the formula for a naught and a1. A1 is basically, what was the formula? Summation xi summation yi dash n summation xi yi dash by summation xi whole square minus n summation xi square. So substitute here, summation xi is 8.8, yi dash minus 1.109 minus n, that is a number of data points, it is 4, to summation xi yi dash, which is 2.542 by summation xi whole square 8.8 square minus 4 into 22.56. If you substitute this, your A1 will come around 1.557. Similarly, if you find out A naught, what's the formula? Summation yi minus A1 summation xi. Summation yi A1 summation xi by n. So summation yi is how much? Minus 1.109 minus 1.157, that is A1, and summation xi is 8.8 upon 4. If you substitute this comes around minus 3. So your A naught is minus 3.703, A1 is 1.557. So from this you get y dash. What was my equation? Your equation was y equals to alpha e power beta t, right? So ln y equals to ln alpha plus beta x. So you had so what we have done is we have fitted between ln y and x. So this was y dash equal to a naught plus a1x, right? So if you compare equation 1 and 2, you can find out ln alpha is equal to a naught. So you have to find out alpha. Alpha is e power a naught. So it is e power minus 3.703, which is 0.0246, and beta will be equals to a1, which tells me beta is equal to 1.157. So the final form of the equation is y equal to e to the power alpha e power beta x. So that is y equals to 0.0246 e power 1.157x. This is my final form of the fitted equation. Any doubts, any confusion?
No, sir.
You understood everything? Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay, fine. Then we'll meet in the next class. Tomorrow, next class, we'll see the MATLAB implementation of this regression, and then we'll move to interpolation, the next unit. Okay, then no homework for this week. We'll meet again next Friday. Next Friday, 6:30. Okay, fine. Thank you, everyone.
Okay, sir. Thank you.
Thank you, sir.
Thank you, Somadip, sir.
Thank you.